students and secondary school leavers to venture into engineering, because we are of the opinion that if engineering is top-notch, Nigeria will move from where it is to where it should be. My name is Niolaniro, and on this show today, my guest is already in the house, but before we go into that, you know, it's a very interactive program where we don't just get to talk to you, you also get to talk to us. So we have a question for you. The question for today is, which bone is the strongest and longest in human? Which bone is the strongest and longest in human? Your guess is as good as mine. That's biology for you. So if you know the answer, just pick up your phone and call us in the course of the program, or drop it on any of our social media handle as displayed on your screen. Then you get a prize from us. It's courtesy of our sponsor, Prince Engineer Yebisi Shilon, FNSC. He is the reason why you get to see us every week, every Friday at this time. He pays the bill, and we are grateful because he's there to sponsor this program and encourage you to join us in the engineering profession. All right, my guest is already in the house. Like I said earlier on, we are going to take this very, very short break. When we return, I will let you know who my guest is and the topic for discussion for today. Glad to know that you are still there, and my guest for today is Engineer ADEDOYIN TALABI, and she's here to talk about a topic titled Engineering Design and Opportunities. Now that topic is very good, very, very interesting, so I'd like you to sit back, relax, and enjoy it. First of all, let me welcome my guest to the show, Engineer TALABI. Welcome to Engineering and You.
Thank you so much. Thank you for having me.
All right. I presume that this topic is going to be very interesting. So I'll just hand over the floor to you, and I'll have you do your presentation.
Okay. Thank you. Thank you so much. So engineering, design, and opportunities. There's a great deal of opportunities in engineering design. And like I had presented in my slide, engineering design, it's all about an iterative way of solving problems. It's a process, it's a creative process wherein you look at problems, you check it, you look for solutions, and before you know it, you come together with solutions, and you're able to pick one out because of the iterative way you have actually used to do it. So it's all about identifying the problem. You state the problem, the need, the desires. So when you do that, then you now try as much as possible to ensure that you gather solutions. You evaluate your values, what you have put together. You gather the solution, you evaluate it. When you evaluate it, what next you're going to do is you now pick a particular one because of different things you have been able to evaluate. So when you evaluate it, you pick it, you will now design it. There's going to be a prototype that you're going to design. When you design a prototype, you actually test your prototype. When you test your prototype, you also redesign it if it needs to be redesigned, and before you know it, you've come up with the solution. So engineering design is all about solving challenges, meeting needs. Normally, engineering is life. It's about solving problems. So the design is when there's a problem, you look at it critically, you evaluate your options, you pick a solution, you evaluate it again. There's a prototype that you create for that solution, and before you know it, you've come out with a problem, with the answer to your problem. So that's what all engineering design is all about. So what are we talking about? Like if you could see on my slide, you can see you identify the problem. Like I had said before, you think about the options, you weigh your options, you look at it. When you look at your options, you try to create yours, because you're not going to, you look at what other people have done. So you create yours, you try it out. That's what I just said, that you're going to create it, you try it out, you build your prototype. So when you try it out, then look at it, what are the challenges in this, what you've just tried out, then you make it better. When you make it better, then you explore again, and you've come out with the solution to the problem. So going forward, you look at the engineering design process. When you look at, like I said, all I had said before, they are into conceptual studies. When you state the problem, when you look at what are you going to do, what is the need, what are we solving. So the conceptual studies, they create a strategy for you to transform a concept into visual media. You transform that concept to your idea into a visual media. It's actually the underpinning successful design process, because if you don't do conceptual studies, you're not going to be able to actually do the rest of the design. So there's a concept that you must come up with a concept. There's a conceptual design that you have to do, like a study. Is this thing going to be possible? Some engineering designs don't even pass the concept stage. Because if you look at it, like I'm thinking of something. This is my concept. How do you put it into paper? It's actually the underpinning of a successful design process, and no project can start without it. So that's number one. Then you go to the front-end engineering design. So we say it is FEED, front-end engineering design. This kind of engineering design approach is used to control project expenses. So many things are done here. You could use FEED to get financial investment decisions. You will use it to make financial investment decisions. So when you're done with your concept and you now come to FEED, FEED will just help you to be able to bring it together. You bring it together and you can take financial investment decisions on your project. When you take financial investment decisions, then you thoroughly plan the project before you're able to move to the next stage, which is the detailed engineering design. Detailed engineering design is usually very, very, very critical. When you get to detailed engineering design, it's a process of designing an object or a system to meet specific requirements. So it's not more like you're trying this or trying that out. You've already put all your concepts. You have already identified the particular way you're going to do. So you're already specific. So you have to design to a specific requirement, a specific need. So that is detailed engineering design. So I also added another one, which is engineering, procurement, construction, and installation. Engineering, like I had said, we have the conceptual studies, we have the FEED, and we also have the DED. So that is the engineering part of it. And most projects these days, they come in EPCI, that's engineering, procurement, installation, and maintenance. So when you look at that, it's a value chain. It's a value chain that everyone can actually benefit from that value chain. So when you do engineering, you go to the procurement, you go to the installation, all of that are all a package all together. So I'm also trying to bring this up to when we look at the Nigerian content. I know the Nigerian oil and gas industry, they've done so well in trying to indigenize engineering. And we have the Nigerian Oil and Gas Content Development Act 2010. And in that Act 2010, there are so many things they have put together. So if you want to do engineering in Nigeria, depending on whether it is FEED or detailed engineering and other services engineering, number one, they will look at it. If it is FEED and detailed engineering on onshore projects, the 90% man-hour must be done in Nigeria. So we have the opportunity. It must be done in Nigeria. So we also have the, if you are doing offshore, if you are going to do engineering and offshore facilities or shallow waters, 90% of the man-hour must also be done in Nigeria. So the opportunity is there. The Nigerian government, they have created that for us, that, okay, if there's going to be any engineering design project, 90% of this, if it's onshore, if it's offshore, is going to be, 90% of it must be done in Nigeria. Of course, we might need expertise from other countries, because we do that a lot. But 90%, you must, any project that you're going to do, you must ensure that you comply. If not, that you're going to, not because from time to time, Nigerian Content Monitoring Board, they come to your project to ensure that you comply to this. So that's why I said there's so much opportunity in that space for engineers, for the upcoming engineers. So we also have detailed LNG facilities. There's a 50% man-hours. We have gas gathering facilities, 90% man-hours. Then the offshore facilities, the hull and the topside modules, 80% man-hours. Then the feed and detailed engineering design on deep offshore floating concrete structures, we have 80% man-hour. So all of that must be done in country. So, but do we have the capacity? Are we encouraging the younger ones to explore the space? And what are the different disciplines? We have different disciplines working. Okay, like now, I'm a mechanical engineer. How do I enter into the space? What do I do? We have the different disciplines. We have the process design. Process design is the basis. If you have an engineering project, if you cannot get your process right, then you might never get every other thing right. You must get the process right. You have the process design, you have the piping. The process design, you usually have the chemical engineers in that space. You have the piping, you can have the piping, you have the mechanical engineers in that space. And you have mechanical engineering too, electrical, instrumentation and controls, pipeline. We have the mechanical too, then corrosion and materials, technical safety, civil structures. Then we have the engineering management. Because I did engineering, but I'm in the space of the engineering management. We have cost engineering. You have the cost estimators. You even have the DCC, that's the document controls. So all of that space, engineers can actually fit into that space. So we have all of that in that engineering design. Are there challenges? Yes, there are challenges. Going forward, there are challenges that definitely come up. Our students, our disciplines, most of them, they don't want to do this. We have the tools we're using, we have the software, we have the workstations. Those tools are always there. That's why most times when I say I'm an engineer, some people will probably you should be on the field, you should be climbing one thing or the other. No, we have our tools. We have different softwares for different disciplines that we use to ensure that we carry out our job. We have the workstations, we have all of that. And now, are there challenges? Of course there are challenges. Our youths, they don't want to do anything anymore. Our youths don't want to do anything anymore. Then we also look at what are the applicable sectors. We have the oil and gas sector, the manufacturing sector, the automobile sector, aeronautic sector, then the road construction. Then, what are the challenges? Like I said, most of our youths they are not ready to actually be taught. Then, non-availability of our good mentorship. This is where the Nigerian Society of Engineers will come in. And I know that APWEN, they are doing great in this aspect. APWEN, that's the Association of the Female Engineers in Nigeria. They are doing great in this aspect. They are bringing up the female young engineers, encouraging them. Then in the STEM space too, science, technology, engineering, and mathematics, they are doing wonderfully there. So most of those things, they try to encourage the younger ones. So mentorship is very, very, very important for the younger ones. Because most times when we finish from school, where do we go? How do we start? How do we do this? How do we do that? Most of us don't even know what was in it for us when we finished. You just meet yourself, you just find yourself doing one thing, and you keep doing it. But if you have been opportune to be mentored, you have a mentor who is usually, talk to you, tell you what to do and what not to do. You know what that means. You'll be better placed than your peers in the society. Then also our engineers, those ones that have even been trained, they go out of the country.
Yeah, that affects everybody.
I remember a few days ago, I needed a particular skill, so I was chatting to someone, and the next thing is, he didn't respond to me on time, and actually I said, have you jackpot? He said, yes, I have jackpot. I tell you that most of the people I worked with 10 years ago, I don't have 50% of them in Nigeria anymore. And the unfortunate thing is, when they go out there, they don't even do what they were trained to do. They do other things. They're all looking for means of survival. You wouldn't blame them really, because we have inadequate infrastructure. The insufficient fund for research and development is there. That we cannot take away from Nigeria. Then we have limited access to advanced technology. And the political terrain too is not helping. We know what it is. We know what it has been. I remember I was on a particular project 2013, 14, 15. And what it was like, this group, when you finish, you are going to be taken to another project. We are not going to disband you. They said, and this is a project that employed more than 200 Nigerian engineers. It was huge, a junior project. And I tell you, immediately the political terrain changed. Things changed. Till today, we have not done the second one that we're supposed to do. So, do you blame the engineers for going? You wouldn't, because our government needs to do more to help even the younger generation coming up.
All right, Engineer Talabi, you have actually opened our eyes to some things. If you ask maybe a young graduate as an engineer, it will tell you, I don't know what is in this thing. I don't know the opportunities. If you ask, okay, we have a caller. Hello. Hello, good evening. How are you doing? I'm sure you want to ask my guest a question.
Yes.
So please go ahead.
So my question is that
Can you speak a little bit louder?
Is the engineering design, is it applicable to civil engineering, whereby we have a construction and particularly building of house?
Okay. Is it applicable to civil engineering? All right. Do you want to try my question to see if you get it?
Yes.
All right, please go ahead.
The answer is paper.
All right. Okay. Mansour, I'll let you know if you are correct. Thank you so much for calling. So my guest will answer your question. He said the engineering design you talked about, is it applicable to civil engineering?
Yes, it is. But like if you look at the disciplines I stated there, I said civil structures engineering. You have instrumentation. Instrumentation, those are the electrical. It's not only electrical, you could, all those mechatronics, they can work in that space. Even I know people who did physics, they are working in that space of instrumentation, not only electric. So we have the different disciplines that can really work in that space.
The question I'm sure will be going through the minds of our young viewers is, okay, how do I take, unless this opportunity, how do I utilize this opportunity that you said is there, untapped in engineering design?
Okay, so the very first thing is, like I said, we need mentorship. And you have to make up your mind that this is what you want to do. So assuming like someone like me, it was when I went for my IT, after doing my IT, I finished my NYSC. The very first company I worked with is an engineering design company, and that was how my own whole career started. So like I said, if such a person has been mentored, even from school, meeting people like us, because I'm actually in Women in Energy, Oil and Gas. We have this thing, we're trying to bring up the younger generations to see the opportunities in what we are doing. So assuming that such people are in such spaces, have such opportunities, definitely by grooming them, you have to be groomed. By grooming them, they already know, okay, this is what I want to do. There's some of them that come for IT, that come for internship, that serve. They look at it, okay, this is what I want. I've even seen people who have come for internship that after that, they said they were not going to do this because they see that maybe there's no money in it. And they left and they're doing something else. So those are the things that we can do.
All right, Engineer ADEDOYIN TALABI, thank you so much for... Okay, we have another caller. Hello, Dablare. All right, can you speak a little bit louder? I have less than 30 seconds to attend to you, so please go ahead and just go straight to answer my question.
My question is, what are the work under engineering?
The work under engineering. All right. So you want to attend my question too? All right. So what are the works under engineering? Can you just maybe
like I said, that engineering is about solving problems. The work, we have piping design, we have process. Okay, if you want to look at those works, that's the discipline that you are in. We have the pipeline specialist, we have the piping specialist, we have the senior, average, senior engineers, the junior engineers. Those are the things they're doing. That's the discipline that you actually enrich into when you are in this engineering design.
All right. One thing you'll be sure of is that this program will do for you is that it will encourage you to go into engineering. And another thing it will do is that it will bring people that will come and mentor you, especially if you're a young person that wants to go into engineering. And such is what Engineer ADEDOYIN TALABI has just done, to mentor you and challenge you that there are opportunities in the field of engineering if only you are interested and if only you take this opportunity and use it for yourself. I want to say a big thank you to you, Ma, for coming to this show. Thank you so much for making it a date with us.
So I have a word to say. I know we have challenges. You know, challenges are part of life. And whenever you see challenges and you surmount it, it will make you to be a better person. So see challenges as opportunities to grow. Thank you.
All right, see challenges as opportunities to grow. So I want to say a big thank you to also to our sponsor, President Janet Shilon FNSC, for doing this and making us come to a viewing pleasure. So for the question for today, Mansuru from Abeokuta, you got it correctly, and the answer is FEMO. So if you are Mansuru, I know you are watching, call this number 0703 161 1497, 0703 161 1497 to claim your prize courtesy of our sponsor. And for the question for the week, because we have to go now, in which part of the body would we be able to find the hammer, anvil, and the stirrup? If you know the answer, please drop it on our social media platforms and we'll get the prize across to you if you get it correctly, courtesy of our sponsor. We have to go now. I want to say a big thank you to you for being there for us, watching us, and thank you so much for joining us. Next week is another time, and we'll bring you another guest by the special grace of God. Until then, my name is Tunde Lanyo. Bye-bye.